Okay, good morning, my dear students. Today we will discuss about the vapor compression refrigeration cycle. So first, we should know about refrigeration, refrigerator, then refrigerant. So refrigeration means it's the process of maintaining low temperature and producing and maintaining the low temperature. So this is called as refrigeration. Producing the low temperature, but we have to maintain the low temperature. So producing and maintaining the low temperature is called as refrigeration. So then what is refrigerator? So this particular effect, refrigeration effect done or used by the machine is called as refrigerator. So refrigeration, maintaining and producing the low temperature. The device used for this refrigeration effect is called as refrigerator. Then what is refrigerant? So the fluid used for producing and maintaining the low temperature is called as refrigerant. So we have a refrigeration, refrigerator and refrigerant. Refrigerant is a fluid for producing this particular effect. Then we will discuss about two things. One is vapor compression cycle, vapor absorption cycle. So in refrigeration we have two different things. We have a compression and expansion. So the most common thing is vapor compression refrigeration cycle. In your day-to-day life, we are using refrigerator in your home. So in the refrigerator in your home, it works under the principles of vapor compression refrigeration. In your vapor compression refrigeration cycle or in your refrigerator, we have a selected four components, main four components in your refrigerator. So the main four component in your main refrigerator is, the first one is the condenser, compressor, evaporator, expansion valve. So this is the condenser. Then we have a compressor. This is the evaporator, and we have a expansion device. All these four main components is incorporated in your household refrigerator. So this is the refrigeration. While using this particular component, how can we get the cooling effect, or how can we get the absorption in this particular refrigeration processes? So here the main component is compressor, evaporator, expansion valve, and we have a this one, what I called this expansion valve. So we have a evaporator, we have a compressor, we have a compressor condenser, we have an expansion valve. This is the most common refrigeration cycle components, main components. Then I can explain one by one about this particular, how can we get the effect, how can we get the chillness effect or effectiveness in this refrigeration cycle. So in refrigerator, we are reserving or preserving something inside the refrigerator. Suppose you can preserve water. So what is the temperature of water in the at the time of preserving inside your refrigerator is, it's a room temperature. Room temperature means nearly 24 or 25 degrees Celsius. Then after some times, if you take or if you feel some cooling effect in the water bottle, then after some times, what is the temperature of cooling? Temperature of water, it is nearly 10 degree, and after sometimes it may be 5. Then after if you take something, it is from, if you take the very low temperature. So the if you beginning if you at the time of preservation, the temperature of water is 26. So after some time, what is the temperature? Temperature becomes 10 degrees Celsius. So how this particular temperature is dropped using this refrigerator. So this is the condition, this is a principle. So we have to find out the working principles of this vapor compression refrigerator. So as a mechanical engineer, you should know what are all the effect, what are the thermodynamic processes carried out in each and every thing. So first I can start from the compressor. So compressor, what is happened here, the input from the compressor is evaporator. So evaporator output may be entered into the compressor. What is the evaporator output? Evaporator output is a saturated or some superheated vapor. So this low pressure, low temperature vapor refrigerant. What is this cycle? If you know this line, you know in this line the refrigerant is flowing in this line. So the refrigerant condition after the evaporator is it is saturated or superheated vapor. This vapor refrigerant is low pressure vapor refrigerant enters into the compressor. So what is happened in the compressor? Where it is compressed. So during compression what happens is high pressure, high temperature. So here what happens here? The high pressure, high temperature refrigerant comes out from this particular compressor. So high pressure, high temperature vapor refrigerant is coming out from the compressor. It is enters into the condenser. It is enters into the condenser. So what happens in the condenser? Condensation means it is just phase change. So phase change in the condenser is the vapor refrigerant enters into the condenser and it comes out with liquid refrigerant. So vapor enters into the condenser. Here just phase changes take place. That is Q out. Q out. So liquid refrigerant comes out at condenser. Comes out from the condenser. Then it is sent into the expansion valve. So expansion valve, the pressure and the pressure is increased. So pressure increased with the high velocity. So here two-phase liquid and vapor mixture, it is entered into the evaporator. So here heat in takes place. So in your refrigerator, the inside the door is called as evaporator. Inside the door is called as evaporator. Here Q in takes place. So this particular compressor, it is almost nowadays in your refrigerator, it is placed at the bottom of the compressor. It is black in color. Okay. Then condenser, it is most of the refrigerator, it is equipped inside. In olden days, it is backside of your compressor, backside of your refrigerator, you have a condenser. So all are having a refrigerator in your home without knowing the working principle. But as a mechanical engineer, you should know the working principles of a refrigerator with the main components involved in this. So the main components involved in the refrigerator is, one is evaporator. Evaporator is where we have to preserve all the things. It's called as evaporator. Then we have a compressor, then condenser, then expansion valve. So what are the things happen here is the refrigerant flows through all these four components. All these four components. The refrigerant comes out with some property. It is entered into the compressor. Then it comes out with some property. So if entering and exit, the property of the refrigerant will change. So the refrigerant is flowing throughout the cycle for getting the effect, refrigeration effect. So this process, these are all the cycles: vapor compression, refrigeration cycle. I already explained to you. It's a process 4-1. Process 4-1. Process 4-1, two-phase liquid vapor mixture of refrigerant is evaporated through heat transfer. So these things I have explained. Okay. Then you come to the process 1-2. Refrigerant enters and it comes out from the top end, from the compressor with high pressure, high temperature. Then process 2-3, vapor refrigerant condenses to liquid. Okay, so this one, it comes out. Then the fourth one, it's expanded. Liquid refrigerant expands to the evaporator pressure. So in each and every cases, we should know the efficiency of each cycle. But in vapor compression or refrigeration cycle, we don't tell it's a efficiency, it's a COP. COP means coefficient of performance. So the coefficient of performance, it is actually output divided by input. So what is the output here? It's a heat absorption. Heat absorption in the evaporator is the heat output. What is the input? Input is work input by the compressor. Work input by the compressor. So COP in terms of enthalpy difference is H1 minus H4 divided by H2 minus H1. So COP should not be more than 1. Should not be more than 1. So this is the, so as a mechanical engineer, we should explain all those things in the term of diagrams. So here pH diagram, pressure enthalpy diagram. So in the pressure enthalpy diagram, we have a process 1, 2, then 2, 3 is the condensation process, then 3, 4, then 4, 3, 4 is the expansion valve, 4, 1 is the evaporator pressure. So this is the pH diagram. So thermodynamic property diagram for your refrigerants. Then apart from this, we have a cascade refrigeration cycle. So in cascade refrigeration cycle, very low temperature can be achieved by operating 2 or more vapor compression system in series. In vapor compression system, which is only one component, that is more than this one. If you take this alone, we are not getting more cooling effect. So if you want very low temperature, means it is a cascade system will be used. So more than 2 or more vapor compression systems are in series, we can get very low, we can achieve very low temperature. So this is called as cascade refrigeration system. So in cascade refrigeration system, this is your pH diagram. Then multi-stage compression. It's a multi-stage compression, means we are having two-stage compression. Here the refrigerant is compressed in the low pressure compressor. Then again it is compressed in the high pressure compressor. Then other things are common. It is called as, that is, refrigerant is compressed 2 times. So this is called as multi-stage compression refrigeration. Then these are all the main things. Then how can we select the refrigerants? So refrigerants to be selected by so many factors. One is performance. So due to performance means adequate cooling capacity. Then safety. Safety is the most important thing to select refrigerants. Then environmental impact. So this is also involved. Then we have a refrigerant types and characteristics. So the refrigerant types, it is different types of refrigerants: R12, R11, R14, R113, R12. Chlorofluorocarbon. Then nowadays, ozone free, we are using R134A. Nowadays, in your household refrigerator, there is equipped with R134A refrigerant. R134A refrigerant due to global warming. So I think we are somewhat experienced in vapor compression refrigeration cycle. So vapor compression refrigeration cycle, the main component is compressor. So here the vapor refrigerant is compressed to get the effective, that is output. What is the output of a refrigerant? Heat absorption. Why heat is absorbed? Then only we can get the cooling effect. So this is the main thing. Then the we are not telling efficiency of an Rankine cycle. We should tell COP. COP means coefficient of performance. So the coefficient of performance should not be more than 1. This is called as vapor compression refrigeration cycle.